Hi, so today we're going to do Chapter 4, Lesson 7, Linear versus Nonlinear Functions. What are you learning today? To determine if a function is linear or nonlinear. Why? So you can compare functions. Why? How are you going to be able to do it? You'll be able to state whether the function you are looking at creates a straight line or not. So is linear or nonlinear. So just like before, you're going to get your information given to you in equations, graphs, tables. So in an equation, you're looking at the x and the y. Is there an x and a y? Yes, that's linear. As long as the exponent is still 1 or you don't have an exponent. The minute you have an exponent, like you have over here, y equals mx squared plus b, that's quadratic. The 2 means quadratic. So this is not going to be a straight line. It's going to produce a curve. If you have x to the third power, you're going to get a wavy line. So curves are created when you have an exponent. So straight lines, no exponent. Curves, exponent. Linear versus nonlinear. In a graph, it's easy. Look, does it draw a straight line? If it's a straight line, it's linear. If it is a bunch of random points, or you see a curve in it at all, nonlinear. If you're looking at a table, you're looking for the constant rate of change. Okay, so again, a table has a constant rate of change. You find the change on the right and change on the left. If it stays constant, it's a constant rate of change and it's linear. If it doesn't have a constant rate of change, then it's not linear. It'll be random points or it'll be a curve. And then there's something called the vertical line test that'll only tell you if something is a function or not whether or not it's a vertical line or a line or linear, sorry. So the test is the vertical line test, and we'll talk about that in a minute. All right, so let's do a couple of practice problems. These are on page 328 and 329 in your book, so you can copy them down from there. So the first one says determine whether the table represents a linear or a nonlinear function. So you're going to look for the change. Remember, you're looking for the slope or the change, so it's going to be y over x. The fact that they put y on bottom doesn't change anything. So 0 to 5, 5 to 10, 10 to 15, these are all plus 5. 20 down to 16 is minus 4. 16 down to 12 is minus 4. 12 down to 8 is minus 4. So it is a constant rate of change. Y over x would be negative 4 over 5. This is linear. On B, you go 0 to 2, 2 to 4, 4 to 6. These are plus 2. 0 to 2 is 2. 2 to 8 is 6. 8 to 18 is 10. So we don't have a constant rate of change here. This is nonlinear. Sometimes they're going to give you a story like they did on page 329. So tickets to the school dance cost $5 per student. Are the ticket sales a linear function of the number of tickets sold? Explain. So again, we're going to look at the change. The change from 1 to 2 and 2 to 3 is plus 1. On the bottom, you go 5 to 10, 10 to 15. This is plus 5. Each one of them is the same, and therefore this is linear. It has a slope of 5 over 1. Okay, so if you can give me a slope, then you can tell me it's linear. So again, we're not really doing anything different today than we've been doing. You're just stating whether or not it creates a line. Okay, so on this example is on page 330. A square has a side length of s inches. The perimeter of the square is a function of the side length. Does this situation represent a linear or a non-linear function? Explain. So they said a square. We're going to draw a square. Side length is s. And we know that the sides of a square are all the same, so these are all s. Perimeter is the distance around. In this case, we're going to add all the distances together, so the perimeter will equal S plus S plus S plus S, or P will equal 4S. Notice that we don't have an exponent, so this is linear. Okay? Your explanation is showing me what the perimeter is. Okay, so the vertical line test I mentioned earlier. A graph represents a function, not necessarily a linear function, because you can see by the pictures none of these are linear. But are they functions, yes or no? A graph represents a function if it is impossible to draw a vertical line that intersects the graph in more than one place at a time. So we have this blue figure here. This is known as a parabola. If I ran a vertical line across, like you see here, you will see it only touches the blue line in one place at a time. So you could go here, 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 but every one of these lines is only touching in one place at a time. Same here. You have this, so this is a function. On the second one, you have a curve in there, so we know it's not linear, but you notice the line will only touch this in one place at a time. So think about the millions of vertical lines going through. Each of them is only touching the line in one place at a time. Even on this curve here, on the third one, again, only one place at a time, no matter how many times we draw the lines. Each line will only touch at one point at a time. These are functions. Down here we have a closed figure. When you have a closed figure, it is automatically not a function because a vertical line will touch in two places at once. Just like on this one here, the last one, you can see that the vertical line is touching in two places at once. It only has to do it once, but we can see if we drew more lines, it's going to do it multiple times. Every time we draw a line, we are going to see more examples of the lines being touched in two places at once. The last two are not functions. Again, this time we're not talking about whether they're linear functions or not, just whether they are functions or not. That's it. Your assignment is on page 321, 322, 331, 332, problems 1 through 12. Good luck.